Hey in there. You can't do that.
Go away. Let me alone.
Now listen. You can't crawl back into your shell. It's too late. You're born.
Well, I'm not sure I want to be. I like it better in here.
You don't think you're the only one born today, do you?
You mean I'm not the only one who has to face that mess?
You sure aren't. Anyhow, it isn't all that bad.
Well, it looks pretty bad to me.
Sure it does. It looks that way to a lot of people. Of course, some people I know are satisfied just to be part of the problem.
Who the heck are you, Mr. Clean?
I'm a steel man.
A tycoon yet? Listen to who's talking about being part of the problem.
Okay. But I just might be part of the solution, too, you know.
Do tell me more.
I will. Open up a little. We'll look around. You'll feel better when you see the work we have in progress.
Duck, everybody. Here it comes.
Across America, the framework of tomorrow is rising now. The construction pace is urgent. For by the year 2000, we must be ready to provide 300 million Americans with food, shelter, education, transportation, recreation, and all the necessities and amenities of a meaningful life. And we must find a way to do all this, and at the same time, restore and improve the environmental heritage, which is a measure of the quality of life. In the nation's effort to achieve high standards of environmental excellence, there are many signs of progress. While many important rivers are still heavy with pollution, some are greatly improved. The Ohio is one. Here is a good example of what is being accomplished by municipalities, industry, and state governments working together. 20 years ago, there weren't any sewage treatment plants on the Ohio River. But today, 99.5% of the population in the Ohio Basin is served by some form of municipal treatment facility. Meanwhile, there is progress to report in the efforts to clean up other forms of pollution. One of the most promising approaches to better environmental management is through recycling of solid waste. There are several developments. This machine, for example, fragmentizes a junk car every 40 seconds. The fragments are separated magnetically. Those containing iron are shipped to an automobile engine foundry to start through the production cycle again. Reclamation of steel cans from municipal solid waste is another important area of resource recovery. Through the use of magnetic systems, billions of steel containers are reclaimed for recycling. Similar systems in a score of communities help extend the life of landfill sites, generate revenues, and help conserve raw materials. The reclaimed steel containers have several markets. They're remelted into new steel in all types of steel-making furnaces. Their tin coating is recovered by an electrolytic detinning technique for recycling. They're used in a chemical process to recover copper from low-grade ore. The steel can recycling program is expected to play a key role in the anticipated widespread use of municipal solid waste as an energy source. St. Louis, for example, is burning garbage to generate electrical energy. Chicago and New York have announced similar programs. The system shown here is a pilot electric generating plant in California, designed to burn shredded municipal refuse as its sole fuel. Plants in other states turn garbage into synthetic oil and gas. All of these systems involve the magnetic separation of steel cans. The steel industry produces the material for 60 billion containers a year. It is serious about recycling them, as it is in all its efforts to create a better environment.
In the steel industry, we are well aware of the demands which population growth and the consequent increase in the need for hard goods will place on us. We must be in a position to increase our steel production and at the same time to improve the environmental aspects of our operations.
The technology of steelmaking is extremely complex. Many separate operations are involved between the smelting of the ore and the shipping of finished steel products. Giant blast furnaces convert iron ore to metallic iron. The blast furnace iron, however, contains some unwanted materials. It must be refined and combined with other needed elements in special steelmaking furnaces. Later, primary mills or casting machines form the steel into rough shapes, which are then rolled or further shaped into the desired forms on intermediate and finishing mills. Each step in steelmaking requires considerable heat and energy, and at each step, there is potential for environmental problems. As you will see, major programs are underway in the steel industry to eliminate or moderate these problems. In every phase of steelmaking, water is indispensable. It cools furnaces, controls temperatures of the rolls and the steel. It cools and cleanses and controls dust. It washes particulates out of stack emissions. Treating it so it can be recycled, used over and over again, is an engineering science. In modern mills like this one, the water systems are planned as an integral part of the plant, extending over miles of pipes to every operation. All used water flows back to the central processing plant. Standing at the master control, the operator can see the whole system at a glance. He can regulate flow all through the system. In some operations, the first treatment occurs near the mill. The water flows into settling basins, where heavy solids like mill scale settle out and are removed. The water flowing onto the treatment plant contains solids, acids, oils, and a variety of contaminants, all of which the facility is fully equipped to deal with. As the water enters, the effluents present can be identified and necessary action taken. The first stop is at the clarifiers.
The primary functions of these clarifiers is to remove the suspended solids from the wastewater as they come into the plant. One of the primary advantages of mixing all the plant waste is that the chemical characteristics of each waste tend to compensate for each other. When the water leaves this final treatment facility and is returned to the lake, it is in a clean state.
Another water purification system being employed in the steel industry today resembles those used in modern municipal treatment plants to purify drinking water. The water from the steel-making processes settles through huge filter beds consisting of sand, gravel, stones, and coal. When the filtering process has done its work, the water that's returned to the mill or back to the source from which it was borrowed is clear and clean. At some plants, the water that's returned is even cleaner than it was when it was first drawn out. At this mill, fish thrive near one of the plant's major outfalls. The water in this stream eventually flows into the Miami River in Ohio. These boys claim that they fish regularly at this spot. Their catch seems to have made it all worthwhile. In some of the newer steel industry water treatment plants, there is practically no discharge at all into streams or lakes because the water is almost completely recirculated. This mill has a closed-loop recycling system in which water is used over and over again. Here, water used to treat slabs in a caster is cleaned in an oil and scale removal pit. The small amount of oil that floats to the top is skimmed off. Heavier scale settles and is eventually scooped out by crane. After cooling, much of this water undergoes further cleansing in deep bed high flow rate filters. The water is then returned to the caster for reuse. This system utilizes a reserve storage tank to protect equipment in case of a water emergency. About 30,000 gallons of water are treated and reused in this unit every minute. Only 300 gallons a minute, or 1% of the total amount of clarified water, ever leaves this system. Some of it through discharge, but most of it through evaporation. In older plants where land is scarce, these massive treatment systems must be superimposed over, under, and around existing facilities, which are already overcrowded. This makes for difficult engineering and high construction costs. Nevertheless, the job is being done. In the parade of private industrial concerns who are making major investments for water pollution abatement, the steel industry is among the leaders.
There was a time in America when a smoking chimney was a symbol of growth and strength and prosperity. Fortunately, this bit of folklore has all but passed from the scene. In the steel industry, it will soon be gone forever. Dust and metallurgical fumes traveling at the speed of sound like this are generated when oxygen is blown into a heat of steel in an open hearth furnace.
This open hearth furnace steelmaking shop has been equipped with scrubbers to eliminate emissions from the stacks. The furnaces are in full operation, but the red smoke has been scrubbed out. The scrubber system intercepts the original stack, which is sealed. The emissions, hot gases, iron dust, and smoke, pass through the scrubber, which is a flat disc arranged to force water to mix with and cool the stacked gases. The model shows what happens inside. Water is agitated so that it mixes with the solids in the gas stream. These settle out as the mixture of gas and water moves upward in a spiral motion inside the vessel called the cyclone separator. Solids in the water drop out the bottom. The gas passes on through a fan and then out the stack. The scrubbers effectively eliminate dust from the stack emissions. This can be seen by comparing the stacks when the scrubbers are on and when they're off. With the permission of air pollution authorities, we turned off the scrubbers on one furnace for just a moment. Then we turn the system back on. The red particulates that had been pouring from the stack are now collected in the water that is agitating through the scrubbers. As a result, what was a red emission now becomes clean white steam. Since the red dust is now in the water, the next step is to clean up the dirty water. This is done in clarifiers, such as these. The solids settle out, and much of this water is returned to the mill. The iron oxide in the water is collected and recovered, so that eventually it too might be reused in the steelmaking process. The efficiency of the air cleaning system is monitored and recorded 24 hours a day. Although modern open hearth steelmaking can be very clean, this process is being rapidly replaced by another method, the basic oxygen process. More than half of the nation's steel is now being made by this relatively new and radically different method. Not only is it fast and efficient, but it permits very effective control of all smoke and dust created during the steelmaking cycle. When the furnace is charged with white-hot molten iron, smoke may be created. On some new systems, these emissions are captured by a vacuum hood above the furnace. Here, a hood slips down to create a vacuum seal around the furnace mouth. The latest and most modern basic oxygen system in the country, in which oxygen is blown into the vessel from the bottom instead of the top, has even more advanced anti-pollution devices. Giant doors that slide shut seconds after the furnace has been charged help keep the dust and fumes from escaping into the air. The smoke and gases are then cooled and treated. There are several ingenious ways that this is done. In one system, like the one being built here, the smoke passes between the plates of a gigantic precipitator. A grid imparts an electrical charge to the smoke and dust particles. they collect on the negatively charged plates. From time to time, these are vibrated, and the accumulated dust falls into collecting hoppers to be removed and reprocessed. Another system intercepts the smoke pouring from the furnace duct. Here's how it would behave if the collecting system weren't functioning. When the system is in operation, the effluents from the furnace pass first through a series of trombone-like coolers, and then into a series of huge bags which work like a household vacuum cleaner to filter out particulate matter. Again, with permission of air pollution authorities, we started this furnace with the air purifying system turned off. Then we turned it on. The results testify to the fact that the steel industry is making good progress in the matter of air pollution control. These modern air cleaning installations cost as much as $20 million each. They contribute nothing to steelmaking efficiency, but they make steel mills better neighbors and better places to work. And they're going in as fast as they can be built all over the country. The question is often asked, after you catch the dirt, what do you do with it? This is a big problem for steelmakers to which much attention is being given. In the Midwest, several companies have joined forces to recycle their particulates at a centrally located sintering plant.
The fine dust collected by the precipitators and scrubbers contains a great deal of iron oxide, as does iron ore. We can recover that iron oxide and put it back into the steel-making process. That's what we're doing here. This process is called sintering, and in it we take the fine powdery dust from the precipitators and scrubbers and clinker it into a blast furnace feed material. The value of the iron recovered does not pay for the cost of its recovery, but it does help out.
At a mill in the east, construction is underway on another facility designed to dispose of these particulates. This plant will take the dust in slurry form from the scrubbers and form it into pellets. These pellets will eventually be used as a supplement for ore in the steelmaking process. The conversion of coal to coke, an indispensable process in steelmaking, presents some difficult environmental problems. In chambers called coke ovens, volatile matter contained in coal is driven off by heating the coal to high temperatures in the absence of air, leaving a form of carbon of high purity, which is used as a fuel for iron making in the blast furnaces. Because internal pressure is generated in the coking process, containment of smoke and fumes is difficult, even under the most careful of operations. The doors enclosing the ovens sometimes leak, and the charging of coal into the ovens through holes in the top sometimes allows smoke to escape. In recent years, good progress has been made in means and equipment to contain these fumes. For example, careful research has led to modifications of equipment and new charging techniques, which are showing great promise. In some batteries, the manner in which coal is charged into an oven can be altered so less smoke and dust will accompany this operation, as can be seen here. Under construction in the Midwest is a new coke oven battery that does away with the customary charging car. In its place, this battery will feature a system of coal preheating and pipeline charging that's designed to eliminate emissions from the charging process. Coal is preheated and dried in a special unit and then weighed out automatically in one of the 6 charging bins. Pressurized steam then forces hot coal from a bin through a pipeline transport and into the oven. The result is a clean as well as an efficient coal charging method. Some new batteries have been equipped with devices for capturing smoke occurring when finished coke is pushed from the ovens. Complex and costly hoods or enclosures have been designed which use powerful exhaust fans to capture the smoke and particulate matter and direct it to scrubbers or other air cleaning devices. In another experimental project, the smoke on the pushing side of the battery is captured by a hood on the coke car and cleaned in a scrubber system on a second car, which moves with the first. Meanwhile, several new and different means of converting coal to coke are being explored. For example, in the hills of western Pennsylvania, a pilot plant is making coke by a new method which promises even further smoke control. It makes what are called coke pellets. Only a few tons a day can be produced here, but construction is already underway on the shores of the Chesapeake Bay in Maryland for a much larger $30 million experimental pilot plant and test run to permit more complete evaluation of the process. The fully enclosed process will considerably minimize air and water pollution from coke making. Steelmen are determined to make the production of coke as nearly smoke-free as possible. Coke, of course, is made from coal. Thus, for the steel industry, coal is a vital raw material. Some steel companies purchase their coal from outside sources, but many firms maintain their own mines. Those that do are playing leadership roles in environmental quality control when it comes to the mining of coal. In underground coal mining operations, for example, acid water discharges have long been a problem, one that has been worked on for years. Various methods have been found to deal with it. The one shown here involves huge clarifiers and settling basins. Lime is added to the water to neutralize the acid and help precipitate out other impurities. After undergoing 30 minutes of mixing in an aeration tank and further agitation in a slow mix tank, the mine water passes to a clarifier where the precipitate settles out. These three beakers highlight the process. The first shows acid water from the mine. The second shows particulates settling out. And the third is the clean, clear water as it leaves the plant. The water, as it returns to a stream and several hundred yards away into a major river, is often superior to the water quality of the tributary into which it flows. Steel companies who are engaged in surface mining started programs years ago for determining effective methods of land restoration. We have been converting them into prime vacation lands and beauty spots. We begin by spraying fertilizer and seed onto the land. A few years later, the area looks like this. And the seedlings mature into valuable timber and a living forest. One major steel company alone has, in the last 20 years, reclaimed thousands of acres by planting millions of trees. Much of the progress that has been made in environmental improvement is the result of years of research by the steel industry's own research facilities. All major steel companies maintain extensive research facilities. Other programs financed by the Iron and Steel Institute and individual steel companies are conducted in world-famous independent laboratories. The work we're doing in this laboratory is part of a continuing research program in pollution abatement that was started in 1938. This effort at Mellon Institute of Carnegie Mellon University was initially devoted to the prevention of water pollution. Today, our efforts have been expanded to include air pollution abatement as well as industrial hygiene, that is, protecting the health of steelworkers on the job.
This is the type of sampling pump and filter that we use in our industrial hygiene work. We bring the small cyclone and filter back to the laboratory where we extract them in this chemical extractor and attempt to remove the organic materials from the particulates collected from the air. The organic carbon analyzer is a device that we use to examine trace organic materials occurring in low concentrations in natural river waters and in industrial waste streams.
Until recently, we determined the effectiveness of waste treatment systems by analyzing samples of the treated waste. Chemical analysis would tell us what substances were present and how much. Plankton were identified and counted using a microscope. From this information, we could infer the effect of wastewater on fish and other aquatic life, as well as on people. We still use these analytical tools, but now we've added another one. It's called bioassay, and it's wonderfully simple. We subject fish and other aquatic life to samples of treated waste and watch for signs of stress. If the fish thrive, we know the treatment process is effective. If they don't, we immediately find out why and try to correct the condition.
As you see, the steel industry is deeply involved in the national effort to improve the American environment. We have developed the massive systems necessary to capture, control, and recycle the effluents of steelmaking. We are building and installing them as fast as our human and physical and financial resources permit. Where new technology is needed, our scientific resources are mobilized to produce it. We have not solved all of our environmental problems by any means, but we assure you that we have assigned the highest priority to this most important work in progress.
Across America, the framework of tomorrow is rising now. There will be more people needing more things. The challenge is to provide the necessities and amenities of a meaningful life for all, and at the same time, conserve resources and restore and improve the environmental heritage, which is a measure of the quality of life. In this endeavor, the American steel industry is proud to be deeply involved. Well, you going to come out and get involved or just sit there and rot?
Well, I didn't make the mess. Why should I help clean it up?
Because you're here. You live, you breathe, you eat, you pollute. Clean environment is everybody's job. So let's quit talking and start working.
Okay, I hear you. Count me in.